prediction that there will be 26 billion things connected to the internet generating data by 2020, which is, outnumbers the humans by at least 2 to 1 by that time. So that's a confident prediction. It may or may not be true, but it signifies the buzz, the industry buzz that's about it, if nothing else. It's certainly true to say that there is an awful lot of investment going on in this area. So IBM earlier this year said they were investing $3 billion in the next 4 years in IoT. All of these big players, and the list continues, are throwing money at this thing, IoT, with a view to thinking if there's going to be 26 billion of them, even if we just get 50 cents per unit, we're going to make some money. So if you look on TechCrunch or something, you'll see, Internet of Things startup X was acquired by Y for so many million. So it's a good place to be if you're in a startup and you fancy being bought by one of the big guys. It's the place to be because there's lots of money floating about. And there's various sides to it. So some people want to deal with the data and the analysis of the data. Some people want to be involved in the traffic, the Cisco people, for instance. Some people want to be involved in doing the hardware, making sure their chips are in every Internet of Things thing. Everyone wants to be the place for the standard. There's a sort of wrestling match going on to see who's going to be the standard, which platform will win. Sort of VHS Betamax thing, or DVD, Blu-ray or HD DVD thing. So there's any number of applications. It's such a broad subject. It could be defined as a thing that senses something in its environment and puts that data onto the internet. So you think of Internet of Things in terms of home domestic settings. The internet-connected fridge is the sort of cliche of the time, which I looked it up for the purpose of this talk, and it actually exists. You can buy an internet-connected fridge. Lord knows what it does. I'm not even sure. It's got a screen on the front, and I think it maybe has a barcode scanner, and maybe it counts something. I have no idea what it does, but it is indeed connected to the internet, and it's a fridge. But in the domestic setting, there's all sorts of activity, temperature control and security monitoring, access control, that sort of stuff. In the city space, you can imagine, signage, advertising, that sort of Minority Report thing where you're walking past a shop and it delivers advertising to you. There's a lot of money in advertising, and there's a big move to tailor that advertising directly to you. So that's cities. Manufacturing's been at this for years, for decades, in fact, but they didn't call it Internet of Things. So back in the day when I was in British Steel, we created sensors to measure hot things, fast-moving metal objects, things that were impossible to measure. Or you couldn't buy a thing off the shelf to measure. You had to build something to do it. And then that data was transmitted to some central server, not necessarily the internet, so not the Internet of Things as such, but they call it SCADA back in the day, and it's been going on for years. So that's not a new thing as far as manufacturing. They're big up in automation. Vehicles, in car entertainment systems, self-driving cars, not really Internet of Things. It's more of an appliance, really, that it may get its guidance from the internet, perhaps. It's not really necessarily sensing its stuff and sending it out to the internet. It's more of a moving appliance. Healthcare is a big thing. It's a big sector, from measuring your fitness to pregnancy prediction and all sorts of things. Energy is like manufacturing. It's been at it for years. And agriculture, you think there's not much to be done there with agriculture. But I was looking at an application the other day where they have lots of remote sites, and they have sort of waste receptacles that are gradually filled up, and it's this company's job to go and pick them up, and it's pointless to pick them up unless they're full. So they put sensors in them, and it pings back to the server saying with the weight or the volume that's in the receptacle. And then when it's reached 90% of capacity, they schedule a trip and then saving pounds, diesel, and all that sort of stuff. So there's plenty to be done in agriculture too. And then there's a drone flying past, which is another sort of Internet of Things thing. So we'll play the little "Is this Internet of Things" game, because as it's such a woolly thing, we'll just see whether you think this thing is Internet of Things or not. This is the humble gas meter, which an old-fashioned one, but measuring the volume of gas coming through from the mains into your house. and then presenting the data as a mechanical dial on the front. Is this Internet of Things? I ask you, audience. No, why not? Why not?
It could be.
It could be, yeah, it could be, but it isn't. It's sensing its environment, which is good, but it's not sending the data. It's not even electronic. It's mechanical. So not quite Internet of Things, but it's got the sensing bit, which is fair enough. This is perhaps the next stage up. This is a two-stage device. You put a clamp around your mains mains cable, a big thick mains cable near your electricity meter, and that senses through induction the current in that cable, and it transmits to this device, which sits in your kitchen, by Bluetooth, and then it presents how much energy you're using. So you switch it on, and it shows you a moving bar, how much energy you're using. You switch the tumble dryer on, it goes, ah, and then you go around the house switching things off and finding out how much energy you're using. It's not Internet of Things. The data is not leaving your premises. It's using Bluetooth to collect data from a sensor and presenting the data, so it's nearly there. But it never touches the internet. You can't view that data on a smartphone. You can't plot energy usage against time on a website or anything like that. So that doesn't pass our test either. This is a fitness app you may have heard of. You install it on your phone, and it uses the GPS and other sensors on the device, and you go for a run around the block. And when you get back, it puts those data points onto your profile in the cloud, and then it presents how many calories you've used. Now this is Internet of Things. It may not seem like it. You're not plugging wires into something necessarily, but it's using sensors that happen to be built into a device that you've got. It's storing the data in the cloud, and it has to deal with a lot of scale. These guys have got tens of millions of users, so that the amount of data that they create when people are jogging is around the world is pretty substantial. And data, as you know, is an asset, and they need to crunch it and look for the patterns and the numbers and sort of monetize it or whatever they want to do with it. So that presents a challenge of scale, which we'll come to later. This is probably a classic Internet of Things device. So this is a thing built for the American market, where it's monitoring the temperature in your house and also controlling the temperature. So it's not only a monitoring system, it's a feedback control system. So it will switch the heater on, the boiler on if it's too cold, and so on. But it also crucially sends its data to somewhere in the cloud, I don't know where, but then you can access it from wherever you are. You could switch the heating on remotely. So this starts to introduce a really crucial part of, or a secondary part of Internet of Things, that is the feedback portion, connecting, not just sensing the environment, but also feeding back and acting upon some actuator or other, and switching something on or off, or whatever you want. Another one is, this is a Philips device. It's a set of light bulbs that you, in various form factors, and a Wi-Fi hub, and you put these light bulbs around your house. They're quite expensive if you wanted to do your whole house, like something like £50 a light bulb, which is a bit steep. But it gives you the advantage of being able to control your lights from your phone app, so you don't have to get up and switch on the wall, which is all the way over there. I can just do it from my phone app. But you can also change you can dim the bulbs, and you can change the color, and you can make it flash for parties and things, and for only £50 light bulb. But also you can connect it to external things, so that IFTTT, if it's then that sort of API service. So you could say, whenever somebody tweets me or whenever somebody emails me, then flash the lights, for instance. All right, then I've got I must check my phone. So so this introduces another aspect of Internet of Things, and that is the composability of it. That if it has an open API and the data is available to, it's not sensing anything actually. It's just actuators, if you like. But if it's composable, you can do your own mashups. You can join this data together with something else. So when your washing machine is finished and you're in the east wing and you happen to be in the west wing, your lights could flash to say that the washing machine's ready. For instance, you could do that yourself. What tends to happen is these manufacturers build their own apps, and the data's in their own app. So your Philips Hue data is in this app, and your Runkeeper data is in this app, and you can't necessarily consume this data and feed it into this. And a pretty humble Internet of Things thing, it only qualifies as an Internet of Things device because it senses its environment. This particular TV has facial recognition and gesture monitoring and voice recognition, so you can sort of bark, you know, bake off at it, and it'll go and it'll go off and find it. So it is sensing the environment. Again, it's not generating very much data, but there you go. So we're coming to a definition of what Internet of Things is. It's a set of sensors, usually, or a set of actuators, preferably both. That's more fun. It must have been connected to the internet at some point, not necessarily all the time, as we'll see. And hopefully it will present that data to you as developers in a form that you can use it, not just use it as an appliance where you can never get access to it. Hopefully there's a means of feedback, like an API, for instance, where you can say, you know, switch the lights on, start the washing machine, whatever you want to do. Therefore, you can then make composable systems, taking the data from one, processing it in another, acting upon it, and switching things on and off. That's the dream. And by 2020, there will be 26 billion of these things. So better get used to it. The big challenge for Internet of Things is power consumption, because battery technology hasn't moved on at the same pace as electronics. So this is a MacBook with, obviously there's a screen on a MacBook, but under the hood here, there's a tiny little circuit board, this sort of big, you know, with an i7 quad-core processor or whatever, and a video card and a RAM and all sorts of, it was all on that little card, and the rest of it's battery, and most of the weight of the device is battery. So if you want to create some wearable technologies that is actually wearable, then you can't afford to have a screen like this and a processor running hot and with a full operating system on it. It has to be pretty minimal and consuming almost no power and transmitting data over a very light protocol. That's the idea. Otherwise, you will end up with power consumption issues, and therefore it's not portable, and therefore it's impractical. So this is where this protocol comes in. This is called MQTT, which is Message Queue Telemetry Transport. It's catchy. And it is designed to transmit data from sensors to the cloud, basically. And it's designed for scenarios where there's where your code is minimal and where power consumption is designed to be as low as possible. You know, tiny amounts of power, little batteries that will last a year, that sort of thing. You know, you think of Internet of Things devices like a Raspberry Pi, which that's basically a desktop computer in small form, and it boots with all these services and a video output and all this. But really, it's a bit of overkill, and it would be far too much power. You'd need a big battery pack to keep that going. So it was invented by IBM. I'm employed by IBM. I will name check IBM. I'm not selling IBM products to you, by the way. It just happens to be invented by IBM back in 1999 as part of their queue product for like RabbitMQ, sort of message queue thing. So it's a pub sub protocol, which means this. I may be teaching you subjects here, but basically a pub sub device means that you can have as many publishers as you like on the left hand side. They're generating the data and they're pushing the data into topics. So if you notice under the publisher it says glin/temperature/room1, that's the topic, and then glin/temperature/room2. So there's a hierarchy like a file system, and the last one says glin/humidity. So I'm measuring temperature in two places and the humidity, and I'm pushing them into this thing in the middle, which is called a broker. And that doesn't really do anything other than queue that data up and then sit on it. It doesn't do anything. It doesn't store the data. It's not a database. It's just a temporary queue. And then if somebody wants to subscribe to it, on the right-hand side, the subscriber saying, I want glin/temperature/star, that's everything starting with that string, it will get a feed of any changes in those, either of those, anything in that wildcard, if you like. So it would get both of those top two devices, but not the bottom one. And the idea of a broker like this in a pub subsystem is that you can work with the sensors know nothing about the subscribers and vice versa, and you can have as many of them as you like. So your middle section is dealing with scale, so that if you invent something like a temperature sensor for an office, and you get 10 customers, you think, hey, this is really great. But then you get an order for another 50,000 and then 1 million. You've got a big scale problem to deal with. And the broker is designed to scale. It's designed to be a piece of software that you can bolt more computing onto, and it'll still continue to work. And its job is really just the plumbing of the inputs to the outputs. And you can add as many of these as you like. So there's this is an MQTT broker. There's things like Apache Kafka, which do a similar thing for data generally, but this is specifically for MQTT. And there's various ones you can pick. So Mosquito is a popular one. It's an open source project. You just download it and compile it and run it. And they're free and open source. That's fine. If you don't want to build anything yourself, you just want to consume it as a service, then there's a site called OpenSensors.io, which is a startup. And they run an MQTT broker service. As a service, you just sign up for an account. And their business model is a bit like GitHub in the sense that if you want your data to be in the public domain, you don't pay anything. But if you want your data to be private, then you pay a monthly fee like you would to GitHub, and then you're allowed to have private data, basically. So you keep your data away from public eyes. And then the corporate one, so this is IBM, of course, and they have a thing called Internet of Things Foundation, which is a commercial product for big companies with lots of data and lots of sensors, which we'll look at later. We'll look at the open sensors thing too. MQTT demo, which one is this? Oh yeah, right, so this is, so MQTT is extremely light. You don't need very much to be able to demo it, actually. It'll run on the tiniest of chips with the tiniest of TCP stacks. But for the purposes of this, I'm just going to, so I've got two windows here. One is going to be the publisher, one's going to be the subscriber. So I'll show you the subscriber first. Let's go. Is that readable? You don't want to read my password, that's for sure. Just hide that. So so basically this is a Node.js program. It's saying, I would like to subscribe to users/Glinberg/justtesting. Now this is an Open Sensors account. So I've created an Open Sensors account and created a topic called Just Testing. And I've created some devices. One is going to publish to it, and one's going to consume from it. And then every time a message arrives, it prints it out. So if I run this, nothing will happen because there is no data being generated. But if I flip over to my other window where I've got another program, make that bigger. So publish.js is similarly got my password in it, which is not desirable. And again, this is just using an open source library. Again, this is Node.js. So it's using a library called MQTT, which somebody else wrote. It sets up a connection with a URL. And then this set interval function is running every 1,000 milliseconds, every second. It creates a payload here. So a payload is a string. And it wants to send the data as JSON. So it basically gets a JavaScript object here, which contains a number, I, which increments, and X is a random number, and Y is another random number. And puts them in an object and then stringifies it, turns it into a string, and then publishes it on the topic we're listening to in the other window. So if I run that here, then this should generate data every second. And if I go to the other window, hopefully, that one should then subscribe to it, which worked earlier. And then, all right, okay, there you go. So live demos, don't you love them? So the idea is you could have as many publishers and as many subscribers as you like, and one need know about the other. The publishing code just throws the data out there. Whether it works or not is dependent on the connection. It's not necessarily retrying. There's a quality of service thing in the protocol where you can say, how keen are you for this data to actually make it? 0 means it doesn't really matter if we miss much, and 1 is it has to get there. I want you to block until it gets there. But of course, there's no guarantees in this world, so there's, stuff might not happen. But it doesn't store things locally. So if you are disconnected, if you're doing a transport application, for instance, like we're putting a sensor on a train and the train travels across the Trans-Siberian Highway and there's no internet connection, then it's not the data is not going to get there. It's just going to lose large tracts of data. So we'll go back to the presentation, which is here. Yeah. So so you can see how you can pretty simply, in a few lines of code, certainly from a high-level programming language, just publish stuff to an MQTT topic. And then you can write another program completely separate that subscribes to the topic and does something with it. It's up to you. But how do you get data back? In the Nest example, say that's taking temperature readings and throwing them into the cloud. How does it know when to switch the heating on? It could, if it's just a device which has its own logic inside, then it can make that decision. But if that's coming from the cloud, say you're clicking on an iPhone app, how does it get that feedback to it? Well, it would then subscribe to its own feedback channel. So on the left-hand side, we've got the sensor and the subscriber at the bottom. So that's waiting for feedback, saying, well, what do you want me to do? What do you want me to do? Whenever the thing in the cloud wants it to switch the heating on, it publishes to switch the heat on channel. And then this subscriber will pick it up. So you can do control systems too. The sensor can also be waiting for stimulus from something in the cloud. That could be your application or whatever you want to do. So if you don't fancy getting into programming, I mean, it wasn't very hard programming. It's a few lines of code, but it can get even simpler than that. Node-RED is an open source project, again, invented by IBM. It just happened to be invented by IBM. It's a visual programming tool. Basically, under the hood, it's Node.js, but it comes with a library of connectors into databases, sources of data, things that process data, and it's an event-driven thing. So you can say every time something gets published on this topic, process it in this way, save it in this database, just by drawing a few things on a web page. And hopefully, I can demonstrate that to you here. So here we have. So this is my program basically, and it consists of two blocks. One is whenever data arrives on this block here, which is coming from sensor ID something or other here, then send that data to Cloudant. Cloudant is a database, one of IBM's bought-in databases, and also send this data to a debugging window here, so so you can see stuff happening on the right-hand side. I think I will show you that now. This is a device I'll come to later, but I'll just plug it in and let it boot up. It'll need power as well. So yeah, so this device is configured to when it boots up to get an IP address, but it's a pretty low-level thing. All it does is measure some sensors here and spit it out to a MQTT topic, and that's all it does. Yeah, so it's gone green, which is good, which means that hopefully I should get some data. Right, cool. So I've got some data arriving, and this is all handled without me really programming anything. All I've done is draw a line from one thing to another. So it's sending me some JSON, and it's saying that my accelerometer in here it has certain values. The temperature is 24 degrees, getting pretty warm, and it's got some potentiometers here which you can move around to change the numbers and so on. So that's pretty straightforward. I haven't actually done any code, and this device in particular comes out the box kind of IoT ready, if you like. You just plug the thing in, and data will pour forth into a sensor, into something that will subscribe to its data. And you can, and there's all sorts of things here. So if you wanted to put that data into MongoDB, or you want to put it in Redis, or whatever you want, there's plugins for everything, basically. And you can do other sort of event-driven things, like whenever an email arrives, pass it, pull out the subject header, send it out to something or other, and make your lights flash, whatever you want to do. So where are we? So that's Node-RED, and it's free, so you can just download and run it, and then you get an environment which you start drawing things from one to another. Alternatively, there's an IBM way of doing it, which is there's a Bluemix thing. You can sign up for a Bluemix account, and then press the Internet of Things Foundations, and you get a Node-RED window like this, and you can just start drawing your code. So let's move on. That's the Node-RED demo. So an alternative to MQTT. So that it's great for really tiny Internet of Things devices which require low power. If you're not so worried about the power consumption, some things are fixed to things which generate their own power, and it's not such a big deal. And if you don't want to lose any data, you want to make sure that your data is stored, then you perhaps want to store that data locally first. You'll need a bigger computing device locally than you would with MQTT, but it's very handy for partially connected systems. That is, mobile phones going in and out of range of an internet connection, transportation systems where they're moving out of range, trains going into tunnels, submarines going underwater, all these sort of things where there's no internet connection, where you want to store the data on the device and sync it later. So there's an example here. So this is a Raspberry Pi, and a pretty ancient Raspberry Pi. It's one of the first ones ever made, in fact. It doesn't really fit into boxes. It's got a pin sticking out of it that shouldn't be there. But basically, it's got a temperature sensor connected to it, which consists of, that's the temperature sensor there, that little black thing, and a resistor, and the rest is just providing power and getting the wiring in. But that's the circuit diagram there. And this green writing here is the code. It's a shell script which will query this device. It gets a block of text back, and somewhere in that block of text is the temperature in times 1,000. So you process the string. I turn it into a blob of JSON, and then I post it to a local database on this device, so that with an 8 gig SD card, I can store quite a lot of readings. And it doesn't have to be connected online to be able to do those readings. All it needs to do is be powered up and it starts sensing its data. So that's nice and easy. You've got offline first data collection. The good thing about CouchDB, which you can install on one of these things, by the way, just with one line, is that CouchDB replicates really well. So you can replicate your data from this device to somewhere else. Another CouchDB instance, for instance, on your machine or on your PC or on a server somewhere, or Cloudant, which is a CouchDB-like thing. So there we go, syncing. Syncing is a one line of code operation. You just say, this database, I would like you to sync to that database. And you can either do it as a one-off operation. For instance, you press a button and that causes syncing to happen. Or you can do it continuously and say, whenever data arrives, make sure it gets synced. But it will always catch up from where it left off, and no data gets lost, which makes it very suitable for data collection on remote things which are partially connected, including mobile phone devices, by the way. So you can create native phone applications, write the data to the mobile phone app, and then sync it to the cloud. And again, coming back to scale, it's very easy to knock something together like this, but then somebody orders 50,000 of them. And it's very easy to get somebody to make 50,000 of these things, but then how do you deal with all the data? And the idea is that with MQTT, your broker is the thing that scales. And with this sort of offline first data collection, you need a database that can scale 50,000 lots of data arriving once a second, and so on. So Cloudant is a scalable database. I'll just see if this one works. I'm going to plug that into. So this is just Ethernet. And this one's the power, which is also coming from the computer, but it's just USB power, which always goes in the wrong way. There we go. It hasn't got any light, so it just kind of comes on at some point. So we'll perhaps come back to that when it's booted up. Otherwise, you just have to watch it. There's a little blue light there flashing, which is encouraging. So yeah, Cloudant is an IBM product. It's free to sign up, and it's a NoSQL database. You can just push JSON documents in. And it scales nicely too, so you can have three nodes. You can have 300 nodes, and you just keep adding nodes to make it scale. You position your data all around the world and sync to it from a tiny device like this to a huge device, set of devices in the cloud, where it can be queried with MapReduce or Lucene or geospatial stuff. It's got an HTTP API. Anyway, that's my intro. So we're going to look at some hardware in decrease from the most expensive to the least expensive. So this is, if you wanted to get started, you were so inspired by this talk that you wanted to run off and do an IoT project. Probably one sort of easiest way to do it is, because you've already got one, probably, is a smartphone. They're only £100 to £800, depending on how flash you are. But they're already connected to the internet, even outside the office. Mobile data. They've got fantastic HD screens for feedback. They've got GPS. They can tell the orientation sensing. They've got a magnetic compass sensor, microphones and speakers for feedback, all sorts of things. Camera, you know, multi-megapixel cameras, all sorts of things for £100, which is great. Although the battery will only last a day, so you know, you strap it to a train to record something, not so good. But still, it's a good way to get started. The trouble is, the software you want to create is probably a bit heavy. You're going to have to learn Objective-C or something else from Apple, or Java with a great big SDK for Android. You can do a web app, but you'll have a job making that run all the time, 24 hours a day, because it'll only run when it's on screen. So it's a good way to get some hardware. You get a lot of hardware for your money, that's for sure, but not necessarily ideal. The next one down is this guy. So that was about 100 quid to 8, let's say, a few £100s. This one is just under £100, and it's an ARM device. So ARM is the other people that make microprocessors for embedded devices. Most of your phones have got ARM chips in. There are already 6 billion of those things around. So this is a pretty low spec ARM board on the bottom side. And on the top is a range of sensors. So it's got potentiometers, it's got an LCD screen, it's got a buzzer, temperature and humidity sensor, it's got an accelerometer thing, and a joystick as well, a little joystick there, you can move up and down. So it's packed full of sensors. And this is the one that's designed to just sort of plug and play. You just, what you do is you plug it in and it will start pumping stuff up to an MQTT service. And if you plug it into a USB port, it'll show, there'll be an HTML file there which will bounce you to the right page, and you'll just start seeing the data. So it's really dead easy to get started. I've kind of done this in the wrong order because I've got this one plugged in. So I'm just going to flip to this this one here. So this is a, if you've got internet. Without internet, we're a bit stuffed on the Internet of Things demo, to be fair. Oh, okay, we're off. Right, so this device, again, just flipping back to this one, this is an ancient Raspberry Pi from back in the day, and it's sensing temperature from here, and it's storing it locally in CouchDB. That CouchDB instance has been told to replicate to a Cloudant database in the cloud continuously. So every reading is sent off to Cloudant. Now then, this is a web app running a Node.js program, which is listening to that Cloudant database's changes feed, because you can get a real-time feed of all the changes that happen to it. And then it's squirting that every change down to this web page using WebSockets. So there's a rather complicated route just to get the data from here to here via North America, probably. But that's life. And the idea is that this thing can just be plugged into somewhere. I usually have it connected with a Wi-Fi port on it, so I don't have to have the Ethernet cable, and it just sits there. And I've had it running for a year, and you can see trends of temperature as you go. I had to switch it off to come here, obviously. So there's a break in the data, but you can see a nice trend during the days. At night, the trend goes back down, and then 6 o'clock in the morning starts to creep back up. If you're a temperature nerd, then this is definitely the thing. And I've got 3 million data points in my database that this thing's collected over the last year, which is nice, and almost completely useless. I don't do anything with data, for instance. I should alert myself when it goes above a certain threshold, or switch the heating on or something. But what's my next demo? Sorry about the slight chaotic. Right, yeah. Question? Yeah, sure.
Is it possible to send feedback back to the Raspberry Pi?
Sure. So if this Raspberry Pi, if that program running on here was to also subscribe to another MQTT channel, it could be waiting for instructions effectively, and then some other system could post to that topic, and this would get it, and it could flash a light, for instance. So yeah, it's pretty simple stuff. So that code I showed you earlier, which was subscribing to a channel, is just 3 lines of code. That's all you need, and it will get real-time updates whenever something changes, which is quite cool. And of course, the thing that's making the data and the thing that's receiving the data are not connected directly; that they're connected through the broker, which is quite cool. There's no hard coding of that this thing is waiting for this particular thing to say. It's just through this broker, makes things simpler for you because you can disconnect things and reconfigure them. So going back to this one again, sorry about this, I should have done it in the right order really. But this guy is the plug and play. So I'm just going to plug it in here. And when that light goes green, it means it's got its IP address and starts creating data. Yes, good. Right, so it starts creating data. So then I've got this thing, which is another web application. And it's sitting there waiting for instructions. So as I move these potentiometers around, it draws the up, down, left, right. You get the idea. It draws them. It receives. This is transmitting data once a second. Goes into a cloud and database. This is listening to the changes feed of the cloud and database, and then drawing things on the screen. And when I shake it around like that, it shakes the thing, and the screen gets cleared. That's the idea. But again, a trivial example, but it's very simple to do. These things take a couple of minutes to put together. Not very hard at all. So we're going to go cheaper. We want cheaper than £100. I know you don't want to spend £100 on something. I can sense it. So you want a Raspberry Pi probably. So Raspberry Pi is this sort of thing. I've put it at £40 if you want one of these things, which is like a Wi-Fi connector. You get a Bluetooth one as well for more fancy things. Out of the box, it doesn't actually do very much in terms of Internet of Things. You can use these pins here to switch things on and off, switch LEDs on and off, or through a relay switch something bigger on and off. But it doesn't actually have many sensors. It has a thing called an I2C bus, which is a bus that you can connect other devices to if you know your electronics. It's like a 3-wire protocol, serial protocol, so you can connect to other sensors if you like. But out of the box, it doesn't actually have any sensors. It has great output, you know, your HDMI output, sound output if you want to make it make noise and that sort of thing. 4 USB. This one's got 2 USB ports, but another one here's got four USB ports. Brilliant. So, and that's only 40 quid. If you want more sensors, you'll have to spend some more money, I'm afraid. Another £30. So we're kind of up to 70 again. And this is a daughter board which sits on top of it here, and this adds a very familiar array of sensors. So it's got a little joystick here. It's got temperature, humidity. It's got a magnet, compass sort of sensor. It's got a gyroscope, and it's got an LED array here which you can use for output. And this just sits on top of the Raspberry Pi and is powered from it. So it's very simple. You can install some software. So I'm going to power this guy up here, and then we'll show. I only got this the other day. It was only released last week. So I'm the ultimate early adopter, I'm afraid. This comes with the territory. So this guy goes in there. Right, that's pretty, isn't it? And so these are LEDs can not only be switched on and off, they can be colored. You can program each color of each and the intensity of each one, which is pretty cool. So when this thing is booted up, again, this is running Linux, so it takes a while to boot up. It's not like the other guy, which just boots up and it's just spitting out MQTT. So you've got a very small program running it. If you want to program this thing, you've got to write C code, and it's pretty low-level stuff, which is fine if you want to get into real Internet of Things. If you just want to mess about, you probably just want a nice familiar operating system like this. You can plug it into your TV and see what's going on and print out messages and that sort of thing. It gets a bit hardcore with the other one. So I should be able to, in another window here, I should be able to SSH into this thing. Pi 2 local. So this is Raspberry Pi 2, so it's got 4 USB ports. It's much more powerful than the other one. It's a really powerful beast of a thing, really. It's like a desktop computer. So okay, so I'm now through this wire SSHing into this device, and inside here I've got a directory called sense hat. Can you see that? Is that too small? Make that bigger. And there's some Python scripts in there. LL, that'll be handy. So so if I want to measure the Python temperature, so this is using the devices on here and then spitting them out onto here, which is, the temperature is 24.9, with an extraordinary amount of precision. Far too much. Far too, yeah, to 8 decimal places degrees C. So that's kind of cool. So, and that's just look at the code to see what did I have to do that. 3 lines of code I had to write. I had to say, I want the sense library, please. And I want the temperature to be get temperature. That was tough. And then I used show message to turn the lights on in sequence so that it would scroll. I didn't even have to write that bit. Then somebody else did that. So if I look at RGB.p, now this thing is programming each LED individually. So you pass it an array of noughts and crosses effectively to say whether you want it on or not. And in this case, I'm saying X is, when I say X, I mean red. When I say O, I mean off. So when I say Python RGB, I get that, which is the same shape as the X is on there. If I change, if I edit that, say Python, no. I edit that and say I want 0 to mean, say 200 there. Vi. Nano, that's right. Okay. If you're using a Raspberry Pi, don't use Vi. This doesn't work. Nano is where it's at. So 200 here. I'm going to put that some. So these are just RGB colors. Then I'm going to save that. I'm going to run it again. So notice it's just still at its last thing. I run it again. Python there. It turns into a sort of color blindness test. With so there are colorblind people, but there's a red. There's definitely a red question mark amongst the horrible lime green thing. But you've got, again, for a relatively small amount, you've got a bunch of sensors. If I wanted to measure the temperature and then send it to an MQTT broker, that's fine too. You just another couple of lines of code, and that would have gone there. I was hoping to have a demo here where I could get data back onto this thing, make lights flash when an email arrived or something such. But so I didn't have time. But you know, you can do that as a follow-on activity. Some homework. So that's £40. Well, £40 for the Raspberry Pi and another 30 for this bunch of sensors. Other sensors are available. This is the official Raspberry Pi one. There are any number of other things you can add on. This is another one. So this is a Texas Instruments device, and it's a slightly different twist on it. So this thing isn't a computer in the same sense as these things. It's not networked at all. It doesn't have Ethernet. It doesn't have Wi-Fi. This is just a Bluetooth sensor. It's in a sort of rubber wrapping thing, but you take that off, it's actually just a small board like this. It's got a little cell battery in the back of it, which lasts a year. If it's spitting data out once per second, the battery will last a year. It's using Bluetooth low energy, so it hardly consumes anything. And it's got a very familiar array of sensors. It measures light, it measures temperature, humidity, gyroscope, and a compass. I think they use the same chipset on all these devices, it seems, because and basically, if I were to get out of that SSH session and run, so this is, I'll show you the code, because otherwise it's cheat. Slightly bigger piece of code here. It's basically saying I would like to detect. You kind of have to set up the Bluetooth pairing thing. So it goes off and senses, are there any Bluetooth things out there? And once you've got some feedback saying there's a Bluetooth device out there, then in an endless loop, read the sensor for, oh no, it's not an endless loop, it's 5 times. Read the data and spit it out, and then wait a second. So it's a bit more involved in this particular instance, but if I can run that one, it should detect this thing. I might have to press the pairing button, which is here. And it discovers this device, and then it measures some device getting even hotter, 26.5, and the pressure it's doing is going to do this 5 times and then stop. And this is a much more portable device, so you can then sort of decouple your sensor from your data collection device. So you could imagine you could have a Raspberry Pi somewhere with a Bluetooth device, and then these things spread around measuring something around the place, and it'll all be collected here, written to a CouchDB database, send off somewhere else. So this is only £20. So we're getting down to bargain bargain bucket area now, and it's got the same amount of sensors as this thing, but half the price. But it's not a self-standing thing. You're still going to need some computing somewhere to deal with it. If you want to go completely hardcore, then this is the thing for you. This is called an ESP8266, which is a catchy title indeed, and that's the name of the chip. And it's basically a Wi-Fi enabled piece of microcontroller, basically. So you write your code in C, and it'll connect to the internet, and you can run an MQTT client on there, so it can write data. But all it's got available is some digital inputs and outputs here. So you could use one of these devices to say, be the thing inside the light bulb that switches the light bulb on, for instance, to be the remote actuator, or to collect switches.
That's the local processor, you mean, for wherever you're doing the central?
Yeah.
Or you're saying it's a central collection?
Well, it's not going to be able to, it can collect data from inputs and outputs. So it could be, say, someone presses your front doorbell, it goes into one of these things and it notices the change and posts to an MQTT thing. Okay. That'd be handy. And this thing could be powered by a little cell battery and it would last for ages because it's hardly consuming anything. The disadvantage is you're going to have to get into some electronics. It won't be able to power things on and off without relays and transistors and all sorts of stuff. So you're going to have to get your soldering iron out there for that thing. But these things are £5 if you buy one of them. If you buy them in bulk and you buy them from China directly, they come in about 50p. So you can afford to be liberal with these things. You can spread them around the place, and embed them in your clothes and whatever. I think there's an I2C thing for this as well. There can be various flavors with various capabilities. This is just one of them. Generally, that you can put this onto another board and then communicate through some connection or other. So we're approaching the end here, and so I'm encouraging you to get involved with IoT-based things. It is a bit of a buzzword. It's easy to be cynical about it because it doesn't mean anything. And people have been measuring and sensing things for years. They've been using computers to automate things for years. It just happens to be getting a load of investment. And if you're in the market for a job or you've got an idea that involves sensing and involves controlling something, if you call it an IoT thing, you're much more likely to be bought by one of the big guys than if you don't. And there's a lot of money floating about in these pools of investment. It's inexpensive to get started, so you can start from 50p if you've got electronic skills, probably more like under £100 if you don't, and no soldering required unless you really want to. Yeah, go for it. So that concludes it, and I'll take some questions. Thank you very much.
Thank you.
Any questions?
What's the most creative project you've seen that's been done?
Well, my favorite one is I was speaking to a guy who he kept bees, and he wanted to increase the yield of his honey production. So he created a hive that was festooned with sensors. It measured the weight of the hive, so it had scales at the bottom. It had a temperature of each. I forget what they call the sort of panels where the combs are. He had little light sensors on the exit of the hive, so you could count the bees in and out. And so he knew how many were in and how many were out, and which direction they were flying in, and what the temperature was at the time, with the wind direction, and And he was storing this data. Often with the beehives, they take them off onto the moor somewhere and then leave them for 3 months and bring them back. So you can't be connected to. You may not get a signal out there. So he was using a Raspberry Pi and storing data locally. That's brilliant. I mean, that's what it's all about. All with the view to making more honey, which is a good thing. So yeah, that sort of thing is great, and it's all it's kind of a hobbyist thing. There's no big corporate overlord doing it. He wasn't using Philips light bulb thing plugged into he's just got a Raspberry Pi and a bunch of sensors, and he knew a little bit of electronics, and he just wanted to collect some data, and to with the view be that he wanted to make better honey, or see why honey wasn't being made, or whatever. But the problem the shame of this thing, if it goes wrong, is that it becomes too siloed, and that you can't get the data out of one system into another. You know, your light bulb, you've got a light bulb app, and you've got a music app, and you've got a dishwasher app, and they're all separate. And none of this stuff will be interoperable, which will be a real shame. So it's up to us, the developer people, to just to subvert that a little bit, I guess, and build whatever you like, and in an open way, and keeping your project open. If you're developing something that creates data, make that data available to the next guy through an API, and then you'll be amazed what people do with the data that you were just storing because you can. So it is amazing. It's like creating open source software. You create something, you say, "Oh, hope that's useful to somebody." Somebody picks it up and changes it to something else. Whoa, this is amazing. You get communities of people around it. So
do you use this around your house as well?
Well, I've just moved house, so I haven't rigged it for this yet. I mean, I was hoping to make a door locking mechanism where I could, you know, as I pull up at the drive, press the thing, and the front door would open, or the garage door would open, all that sort of stuff. I've never really wanted to drill into the, you know, I'm a bit scared of I was doing electronics at Salford University and they kicked me out, so I'm not sure I should be doing that. But yeah, I'm just a tinkerer really. But I think a lot of it's a buzzword, looking for a solution or looking for a project. You've got to have the idea, like the honeybee thing. You've got to have a great idea, and then the rest will flow. Otherwise, you'll just end up measuring temperature and humidity and the thing. Whatever these devices do, it needs an application.
Is there any overlay software that you could use for this? If you're interested in getting a child to start, playing around with code?
Yeah, that's a good point. I think that Node-RED is almost the simplest way of doing it. It's a visual programming language. It's not writing in text editors. I mean, I'm kind of a command line guy, so I feel at home there in a black screen with green writing, and I'm away. But you forget that kids are going to go, "What is that?" You know, and drawing lines between things is pretty straightforward. I think there are some child-friendly projects for Raspberry Pi. There's an awful lot of things. There's a thing called Project Cano, which is a kit you buy with the Raspberry Pi. You get a keyboard and a bunch of sensors, not sensors stuff, but maybe a speaker and that sort of stuff, and projects that the kids can do, and they end up building things and kind of learning computing by accident. But not necessarily Internet of Things stuff. It's just really computing things, getting people into computing. So the sensing stuff is a different layer on top of that.
So is Arduino the same as Raspberry Pi?
No, it's similar. You would probably not be able to tell them apart if you held them side by side. They just look like a little circuit board. But Arduino was around before Raspberry Pi. It's just another standard for the layout of the board more than anything. So you can get like
the same things, because I've got an Arduino kit.
Yeah.
That I did a course at Maglab and that.
Right.
So I've got all the lights and all like the dimmer switches.
Yeah, you can get, and the Arduino is a kind of computing, they're called shields in the Arduino terminology, but it's basically a circuit board with the computing chip, and then you can put another shield on top which makes lights go, and another one which takes inputs in, and so you can kind of build these things in a modular way. It's a big community, actually, the Arduino community, but it's not necessarily compatible with Raspberry Pi, who started really just to say, make computers available for 25 quid, and to get kids programming rather than consuming computing as an appliance, which is kind of what happens. They turn into an iPad. I remember when my son saw a Raspberry Pi, he said, "What's this?" I said, "It's a computer." He said, "That's not a computer. It hasn't got a screen, hasn't got a keyboard. So that's that." So don't go telling me that is a computer, because it's become they've become commodities, like Sky Plus or something. You just push, it's a computer and underneath, of course, and the hard disk in it and whatever, but it's just an appliance. You just plug it in. Nobody knows how it works. It's just some sort of magic.
So I'm curious about security and privacy. What are some of the privacy concerns you see with your 26-bit devices
Right.
to the internet?
It's a very good point. Very good point. So MQTT as a protocol isn't secured. So when back in 1990, whatever, when they were building this thing, it wasn't considered to be an issue. So, but it's a big problem, right? So if I was able to hack into your home network, post to a topic which opened your garage door, switch your oven on, whatever, release the bees, or whatever it is, then that's trouble, big trouble. And so the latest sort of MQTT brokers are secured, the passwords and stuff, but you're opening up with 26 billion attack vectors, if you like. Each one of these will have a key or a token which allows it to post data, and if somebody can compromise that and know the token or the certificate or whatever, then they have access to be able to generate spoof data, which is bad. So privacy is going to work itself out as things do. The internet, World Wide Web wasn't built with privacy in mind, and it was HTTP only, and now we're just playing catch up really after people have found the holes. But the same thing, it's the same principle as the World Wide Web in that sense.
Yeah.
The end, you need security from the device to the cloud and back over, but security costs you in terms of computing resource. It needs to be a more powerful computer to be able to encrypt stuff. It's much simpler for it to say, it's just sending 18 bytes of data for a temperature. If it wants to negotiate to get the certificate, you have this key and then you sign this, and just to send the 18 bytes, then you're using more bandwidth and more computing power, which will drain the battery. So yeah, it's a problem, all right. That will have a solution. Okay. Well, thank you for attending. Great to see you turn out. And, see you
Thank
again.
you so much.
No problem. Thank you.
Thank you so much, guys, for coming. Philip wanted to talk about an event at IoT Trader at the end of the month.
No, I'm at Auto Trader, and I thought you might be interested.